Hi folks. So we'll continue with the earlier video on this topic. As you might recollect, we discussed the processor understands some language. It's called its machine language. And that machine language it understands consists of a sequence of instructions. And let's say if we have a 3-bit processor, the entire the space in which we have to impart meaning to the instructions is bound by those 3 bits, right? So they are like 1, 2, 3. There are 8 of them, right? 2 raised to power 3 is equal to 8. All right. So this would be a rather primitive processor, but let's say this is what it is. All right. So these then would be these then could be the instructions that can be given to this processor using the machine language it understands. All right. As you might remember, the meaning has to be imparted by us. We are the designers, right? Or whoever designed it. When I say us, I mean the humans, not the machine. Okay. So let's say this 000 means add, 001 means multiply, so on and so forth. There are 8 total instructions that this processor understands. All right. So the entire set of instructions in the machine language that a processor understands natively is called the instruction set of the processor. All right. Okay, so let's move forward. This is important to keep in mind. All right. Now let's try to understand that it is very cumbersome. In the very early days, it used to happen like this. Computers were programmed by programmers using the machine language, but that was very, very cumbersome and low efficiency, right? Because it's not easy to, think in terms of 1 zeros and consulting the instruction manuals and then thinking, okay, what is it that I'm trying to do? Where is it that this processor fits in the system? And all right, let me do this, add first, load here, load something into the memory first, into the registers first, using this instruction and that. It's very, very cumbersome, very, very low efficiency. And hence, it was quickly changed. People realized that they could do better. All right. So this is important to understand. And hence, we came up with the concept of higher level languages, right? Higher level languages, which is basically, there's a very good rule of thumb to understand what do we mean by higher level languages. So let's say this is the level, and the level goes from low to high. This is low level, lowest, and we keep on moving up in the level chain, let's say. So this lowest level is the level that is a level native to the machine, right? Native to the machine. That would be what a processor natively understands. That is the machine language. You can't go any lower than that. That is the lowest level of a computer language. Why is it low? Because the yardstick, the fundamental mechanism to assess the level of a language is this. And as you could guess, what is the highest, or at least high level, as you move up the levels of computer languages? What is a high level language? It is closer to human beings, right? Human intent and human thought. So anything which is closer to human intent and thought, the closer it is, the higher level language it would be categorized as. All right. So let's have a look at how different languages score on this scale. So the lowest is, of course, machine language. So after that, we have assembly language. And C is pretty much the next guy. So assembly is higher than machine language. C is higher than assembly language. And let's say for the sake of discussion, Java is higher than C language and probably Python, and the scripting languages are even higher, so on and so forth. And then this is a continuing effort of making new computing languages to suit us better. Okay, so this is important to understand, so I'll repeat. The lowest level of a language is machine language, natively understood by the processor, the machine. The more you move towards the human intent and thought, the higher you consider the language to be. All right. And why is that so? Because, the machines are our slaves, so to say, because we, the humans, we, the developers, we, the designers, we, the application programmers, we, the application users, we have created these machines, the computers, to do something we want, right? We want them to serve our purpose, whatever that purpose might be. Hence, it is important what exactly is our intent. What is it that we are thinking? What is it that we want the machine to do? So we are the fundamental anchor of the levels of a computer language, right? All right, so just to give you an understanding of the type of language that things could look like. So if we are talking about machine language, as we have discussed, this looks like just a sequence of ones and zeros, etc. So the assembly language does a better job. Amongst other things, it creates opcodes. So what are opcodes? Opcodes are basically things, in a sense, for humans to help the humans remember what a certain machine language instruction actually does, right? So let's say if 101 means add, so the opcode for this instruction machine language would be add. And let's say if 111 means subtract, the opcode for this would be subtract, right? Let's say maybe it is sub. So in this case, add and sub are words in the assembly language. So this, you can clearly see this is closer to the human thought. At least it looks somewhat closer to a human natural language, English. And hence the human thought process can be more efficiently utilized in programming the processor. So the same thing keeps on continuing further, and our focus over here in this sequence of video lectures is C. So from the next videos, we'll deep dive into C. All right, we'll see you in the next video. Have a good day. Bye.